Alright, hey everybody. This is actually my second attempt, but this is probably going to actually be our first real video. I accidentally hit the wrong button when I was doing this the first time. This week, I'm covering some stuff that should be a review for most of you, but if not, I wanted to make sure you got to see it before we got to our last section for this unit. And that is, I want us to go over some basic things about complex numbers. So a lot of the stuff should be already familiar to you. If not, it should be relatively quick and simple. Um, if you need something more complex than, or if you're having trouble with any of this, I just hope that you'll please let me know. You can leave a comment, or you can send me a message, or however it is that you can get in contact with me. I'd be happy to try to help. Alright guys, so the first thing we have here is we're going to talk about imaginary numbers. So to be able to get to the complex numbers, we're going to go through the imaginaries. An imaginary unit I is defined as the principal or positive square root of -1. So this is I. So I to the first power we'll just call I. So let's talk about some other powers of I. So if so the first power is square root of -1, then I squared would just be -1. And I cubed would be I squared times I, so it'd be -I. Because I squared is -1 times the I, give me -I. And that would mean that I to the fourth would just be I squared twice. So that would be -1 times -1, which is +1. So I to the fifth power would be I to the fourth, which we already know is 1, times I, or it'd be I. I to the sixth would be I to the fourth times I squared, which we know is -1. And then I to the seventh, I think you can kind of follow the pattern and see how that's going to be -I, and I to the eighth, you can see it's going to be 1. And you can see that this kind of goes in a pattern. And that pattern has to do with its divisibility by 4. When we're dealing with positive powers, its remainder by 4 will directly correlate to um, the correct simplification. So here it is when our power is positive. As we saw, when the remainder was 1, if I divide it by 4, get a remainder of 1, I'll have I. If I divide it and have a remainder of 2, I get 1. If I divide it and get a remainder of 3, I get -1. And if it divides evenly by 4, there is no remainder when you divide by 4, then you end up with +1. Here's what happens if it's negative powers. It is slightly different. Notice there's a little change between the 1 and the 3, okay? But the rest of it remains the same. So if we wanted to simplify I to the 53rd power, one way we could think about it is thinking about what 53 divided by 4 is. And if I take 53 and divide it by 4, then you end up with a remainder of 1. 13, remainder 1. And a remainder of 1 tells me that my simplification is just I. Here we are with -18. Take that and divide it by 4. When I do, I get -4 up here, so that's -16. Subtract, and you end up with -2. So -2 is my remainder, which means I to the -18th power is the same as having -1. Alright, so that's simplifying these things. So one of the easiest ways to simplify is to divide by 4, get your remainder, and then use that remainder to know what the answer should be. Now let's talk about complex numbers. So if you take real numbers, some of a real number, and um, real number multiples of imaginary numbers, then what you end up with are complex numbers. Their standard form is a plus bi. A is the real part, b is the imaginary part. So some examples are 3 plus 4i, 2 minus 1/2 I, square root of 3 plus pi I. All of these are real numbers on or a real number and a real number multiple of an imaginary number added together. Also 0 plus 5i, or just 5i, is also complex. 3 plus 0i, or just 3, is complex. All of those are complex numbers. Now there are maybe more specific words that I could use to describe these things, but all the numbers that you've dealt with in the like this are all complex numbers. So let's talk about some operations. Let's add and subtract some complex numbers. To do that, when we're add or subtracting, we're going to add the real parts and or sum them up, I guess is the better terminology here. We're going to sum the real parts and we're going to sum the imaginary parts. So 5 plus negative 2 is 3. Negative 3 plus 4 is 1. So 3 plus I. Got it into the form of a plus bi. 10 minus 14, negative 4. Negative 2 minus negative 6, or plus 4i. So adding and subtracting complex numbers is super simple and easy. So let's talk about multiplying them out. To do that, it's a little bit different. We're going to use our old friend, the distributive property. So I'm going to distribute this 2 into the 7 and the negative 4 and get 14 minus 8i. I'm going to take my negative 3 and I'm going to distribute it into the 7 and the negative 4i and get negative 21i plus 12i squared. Now we're going to combine together our like terms. So I got negative 29i and 12i squared. I can do something with that. That I squared is equal to negative 1. So this is the same thing as saying negative 12. 12 times a negative 1. 14 minus 12 is just 2, so I end up with 2 minus 29i. Last one, this number and this number, y'all should see look very similar to each other. They are actually conjugates of each other. So I'm going to multiply them out. 4 times 4, 4 times negative 5 gives me 16 minus 20i. 5i times 4 and negative 5i gives me plus 20i minus 25i squared. The plus 20i and minus 20i will reduce to give me 16, and this reduces to give me plus 25, and we end up with 41. So one way that we can see that a complex number might turn into a real number only is by multiplying by its conjugate. Okay, so let's talk about what happens if we divide things. How am I going to get it into that very nice a plus bi form? Well, to do that, we're going to use what we just talked about with the conjugates. So you can see I know that a plus b times a minus b gives me a squared minus b squared. That's like an old factoring difference of squares, right? So here I am. I want to get this bottom part to not have an imaginary piece anymore. And we just saw in the last example that we can do that by multiplying by our conjugate. So what we're going to do is we're going to multiply by 1 plus 2i on top and bottom. Why do we multiply it in the numerator and the denominator? Well, that way we are not changing the value of our fraction. So we're just going to multiply the numerator by 1 plus 2i. We're going to multiply the denominator by 1 plus 2i. What we end up with when we distribute is 5 plus 10i minus 3i minus 6i squared all over. Multiply this thing all out, and you'll get 1 minus 4i squared. Combine like terms. This is the same as plus 6 because negative 6i squared is positive 6. So that's 11 plus 7i all over 5 by the same logic. So 11 fifths plus 7 fifths I. Alright, so dividing it takes a little bit more time, a little bit more thought, being a little bit more careful, but remembering to use conjugates is going to save you a lot of work. Alright, there's only one more real big thing that I want you to know how to do, and that's how to plot numbers, complex numbers, on an Argand diagram. And so to do that, you need to know what an Argand diagram is. Here it is. An Argand diagram has a real axis and an imaginary axis. So if I want to plot the point 3 plus 4i, it's just a visual way of representing complex numbers. I would come 3 out in the real axis, 4 out in the imaginary axis, and then that is my point 3 plus 4i. If I wanted to plot something like 2 minus 6i, then I'd come out 2 and down 6, and there would be my point 2 minus 6i. You can also plot things like 5i just by going up only on the imaginary part. There's 5i. And you can plot things like -2. Well, it'd be over here just on the real part. So all complex numbers then can be plotted on this Argand diagram, and you can kind of end up with a nice visual representation of your complex numbers. Alright, that video is going to do it for us today, guys. If you have any questions or if you have any trouble with any of the work that I've provided for you guys, please let me know. I'd be happy to help in any way I can. And take it easy, guys, and be safe.